Happy Monday, you guys. I hope you all had a great weekend. I hope you and your family were able to do something fun, either inside the house or outside of the house, by way of taking a walk or something, or taking a drive. Let's go ahead and get into today's lesson by reviewing our big question and what we've been learning. So our big question, again, is how does sound energy travel? What we've learned last week, we've learned that sounds can travel through different kinds of materials. And when we talk about those different kinds of materials, we're talking about air, we're talking about water, and we're talking about the ground. And when we think about the ground, we're thinking about solid materials, just like we did the observations last week. Solid material could also be a wall, it could be a door, it could be a table, anything that's solid. Last week, we also learned that materials are made of particles that are too small to see. Our simulation has been helping us understand particles and helping us sort of be able to visualize what particles could look like if we were able to see them. But the particles are so small that even as we sit in front of our laptops or our phones watching this video, there are air particles that are actually moving around us. They're just too small that we can't even see them. So we're going to continue on and answering the question of how does sound energy travel by actually investigating some collisions today and sort of start visualizing how particles collide into one another and how they actually help us hear the sound waves. Key vocabulary, these are the words that we've been talking about that we learned last week. We learned what material meant, vibrate, collision, as well as particle. Again, I ask that you use these definitions so that we are all on the same page as opposed to Googling these words and using the definitions that come up on Google. Sometimes those definitions are way more advanced, and sometimes the definition is just longer than what you actually need to understand about the word. So please remember to use these vocabulary words, which are always found in your classwork. Thinking about the classwork, we're going to go ahead and switch over and introduce that. So this is today's classwork, again, investigating collisions. You are going to watch, and we're going to watch a video with me experimenting with coins, thinking about how objects collide into one another. This is the link to the video if you like to watch the video by itself as you answer the questions, but we are going to, inside of this video, take a look at the coin experiment as well. Our objective for today, I will be able to create a model that shows the energy transfer in a particle collision. So our model is actually going to be the coin experiment. The coins are going to play the role of a model for us so that we can start to see how energy transfers in a particle collision. These are the vocabulary words. I didn't include the definitions because we have 4 up here, but the definitions are in the previous classwork assignment. So if you want those definitions, feel free to click on one of last week's assignments. As usual, you have your PDN. There are 2 questions that are connected to this image. And then we have the other classwork that you're going to work on independently. So what we're going to do is investigate energy transfer through the coins. And we're going to watch that video, but I want us to first get through the directions and the materials that you need. So what you're going to do, you're going to watch the coin experiment video. Again, the link is right here in your heading, but we're going to play the video as well in this instructional video. And then you're going to answer the questions below. And here comes the very fun part. So this is optional because you are going to need these materials. So you can complete the experiment at home if you have these resources. I am going to use 3 pennies and a nickel, but let's say you don't have 3 pennies and a nickel at home and you really, really want to try this experiment at home. Feel free to use a quarter. Feel free to use a quarter and 3 dimes. Feel free to use a nickel and 3 dimes. You want to try to have a heavier coin and then 3 lighter coins. So go for it and try it out at home. The fun thing about trying this experiment at home is if you want to use more than 4 coins, go for it. This is your experiment, so you can totally have fun with it and be creative. Here's investigation 1, which we're going to talk about in the video, but for investigation 1, you're going to place 1 penny and 1 nickel on the desk in front of you. And then we have some questions about that. For investigation 2, you're going to place all the coins on the desk in front of you, and then your goals are right here, but they're going to be mentioned in the video as well. And then you have 2 more questions for investigation 2. Don't forget the last page right here. Sometimes we stop right here and don't continue on. Please remember to scroll down all the way so that you don't miss out on any work, because you want to turn in high quality work and get full credit. So here you are just reflecting on the investigations by answering these 2 questions. How do the coins model particle collisions? And when you think about how the coins are going to model particle collisions, think about those orange dots in the simulation and what those orange dots represent. You want to think about what the coins represent as we go through that investigation and see those coins colliding into one another. Question 2, when the coins collide, what happens to each coin? So as I go through the video, make sure you're listening to the language that I use. It's sort of a hint, hint, nudge, nudge to help you answer this question number 2. Let's go ahead into the video so that we can start answering questions for investigation 1 and 2. To help us see how energy is transferred in particle collisions, we're going to do 2 different experiments today, but both experiments or investigations will cause us to need these materials. We need 3 pennies and 1 nickel. You're going to watch this video to answer the questions in your classwork, but if you'd like to try this experiment at home, feel free. Just ask your parents for some coins or see if someone in the house has these coins, and then you too can do the experiment at home. Okay, for investigation number 1, we only need 1 penny and 1 nickel, so I'm going to slide over 1 penny and 1 nickel and leave those 2 pennies over to the side. I have my penny and I have my nickel. Now the goal for investigation 1 is for me to move both of these coins without touching the penny. That means I can touch the nickel, but I cannot touch the penny with my finger. So this I can move. Now, I cannot move the penny with my finger, but I can move the nickel. And the goal, remember, is to move both coins. So I'm thinking that I can move this nickel and try to get it to bump into the penny, causing both coins to move, which is reaching my goal. So I'm going to try that. Both coins moved. I reached the goal. In your classwork, you need to be able to say, what did Miss Adams do to get both coins to move? Now I'm going to go to investigation number 2, bringing all of my materials back together. The goal for investigation number 2 is to, without touching the pennies, to make all of the coins move. So for this investigation, I need all of the coins. So I'm going to go ahead and shift them over a little bit. I have all of my coins. I have 3 pennies and I have 1 nickel. Now, just like investigation 1, I cannot touch the pennies with my finger. I can only touch the nickel. I need to get all of the coins to move. So I have to think, how can I do that? Just like I moved in investigation 1, both coins, by moving the nickel towards the penny, I am going to try the same with this investigation. To help with that, I am going to try to line up my pennies to make it a little easier so that I can make sure all the pennies get touched. Because don't forget, the goal is to move all 4 coins. Now I am going to try to move the nickel and see if I can create enough energy to get all 4 coins to move. Let's see if I can do it. Success. So I moved the nickel into that first penny. That first penny then did, what did the first penny do to the second penny? What did the second penny do to the third penny? And this little guy actually moved a lot further than these two pennies. I'm not going to tell you the answer to those questions. I want you to think about it as you complete your classwork and write down your observations for both of these investigations. To help us. All right, so that was our video, and then after you watch the video, you want to go ahead and answer questions 1 and 2. So for investigation 1, and this is where it comes in handy of having this video up here in case you need to pause it, or you can feel free to pause the instructional video and rewind it to go back and replay it if needed. But you want to answer these 2 questions. So for investigation 1, remember, without touching the penny with either of my hands, I needed to move both of those coins, the penny and the nickel. So question 1, how did Miss Adams get the penny to move without touching it? That's what you want to answer there. And again, if you need to rewind to replay the video of me doing investigation 1, go ahead and do that. Question 2, what did you observe? So for that, you can use your hearing as well as your sight. What did you see me do? What did you hear if you heard the coins collide? Be very descriptive in your observation right here. Don't forget your sentence starters as well. So for investigation 2, if you remember, without touching the pennies, I actually had to get all 4 of the coins to move this time. So what did I do to get all 4 of the coins to move? That's what you want to answer for question 1. And then question 2, again, you want to be very descriptive, meaning give me all of those juicy words when it comes to describing what you saw or what you heard in the investigation. When you get to the reflection piece, you want to think about how those coins represent or how those coins model particle collisions. When you think about those coins bumping into each other, we know that another word for bump is actually to collide. So we saw the coins collide. How does that actually model or represent particles colliding? Question 2, when coins collide, what happens to each coin? So this is when you want to put your engineer hat back on as well and think about what's happening when 2 objects are moving, when they move towards each other and when they collide into each other. What is happening in that moment? So you want to make sure you're completing all of this classwork. Make sure you use your sentence starters. Feel free to click on the link again to play the video or rewind this video so that you can play the investigation again, because I really want some good answers and I really want you to put your scientist hat on and really give me some good observations. So make sure you play it as many times as you need to. I'm also excited to hear about any experiments you try at home. So if you want to record yourself, or if you want to take a picture if you completed the experiment at home, feel free to text me or send me a private comment in Google Classroom. Let's go ahead and get back to our slideshow. So here's a diagram of what we actually just saw in the coin experiment video. So I had the nickel, I had the penny. I actually flicked the nickel with my finger to hit the penny, and so we know that the energy is being transferred from the nickel to the penny. And if I ask you, well, what is the source in this investigation or this experiment right here? The source, don't forget, is where something comes from. So where did we get the energy from, right? And although the nickel gave the pennies, the energy was transferred from the nickel to the penny. Well, what energy, or how did the nickel actually get energy to move towards the penny? And so the source of that energy would actually be my finger. So if you were to do this experiment at home, the source would actually be your finger. Your finger shifted this nickel into the penny. So that means energy came from your finger to the nickel. Energy was transferred from the nickel then to the penny. And so when I think about investigation 2, in this diagram right here, I see all of the pennies that were stacked, which is what I did in my investigation. And then I have the nickel here, because remember, your fingers could not touch the pennies. So what happened here? My finger pushed the nickel, which caused the pennies to actually move. So the nickel sends energy to the pennies, which cause the pennies to move. Now, what is the source in this investigation? Well, the source is my finger. Because in order for the nickel to hit or bump the pennies, my finger needed to actually move and touch the nickel, creating energy right there. So my finger, which is the source, sent energy towards the nickel, which then sent energy to all three of the pennies. And in the video, you saw all three of those pennies were actually able to move. So that is energy being transferred from the source onto the different objects, as well as right here. Let's go ahead and think about that when we think about sound waves. So when we think about sound waves moving and traveling from those dolphins, don't forget the source is where something comes from. So if this is the mother dolphin that's creating a sound or a whistle for her calves, how is that energy being transferred, right? The energy is being transferred. Don't forget the energy is moving away from the source towards the listener. So if we go back to this diagram, we have energy that is moving away from the source, which is the finger. It is moving away from the source every time we did an investigation. So that translates right here back into waves. How does that work in waves? The energy is being sent through the water towards the listener away from the source, which would then be the mother dolphin. Let's go ahead to our big question and see what we found out today to help us answer that big question. So how does sound energy travel? Today, we were actually able to see that sound travels as a series of collisions between particles. So we made those coins collide into one another, and we saw that those coins could play the role of particles, right? If those pennies were particles, we were able to see those pennies collide into one another, which shifted or moved towards the listener. Then we also learned that sound energy travels as a wave. The particles of the material it travels through move only a little. So those pennies didn't really bounce across the floor. In my experiment, they shouldn't really bounce across the floor or the table in your experiment, which tells us that these particles are not moving in large distances, but they're actually moving in shorter distances because they're only moving a little. So these are the things that we are continuing to learn to help us answer this big question, because don't forget, at the end of this big question, we are going to need to help the superintendent, and we are going to need to send that information to the superintendent. Don't forget your exit tickets, making sure you do the class assignment and the exit ticket so that you can get all of your points. Don't forget to send me any private comments or text messages showing me your experiments at home.